Okay, welcome back to Math 65. Looking at the next example of 4.1, look at some special cases. Okay, graph these two lines to find the solution to the system of equation. Because let's think about it for a minute. How many different ways, how many different places can two lines cross? Really, you could have them cross at one point. Could you have any lines that never cross? Oh, parallel lines never cross. Or you could have the exact same line that intersects itself infinitely. So we have three different cases, and we're going to define those in a moment below. So again, my favorite way to graph a line is to put it into slope y-intercept. So I'm going to do that first. I'm going to subtract 6x. I get negative 3y equals negative 6x plus 9, because it's a positive 9. I'm going to divide everything by negative 3, and I get y equals 2x minus 3. So if I want to graph that, I go over here. Here's my y-intercept, 0, negative 3. From there, I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. It's a little awkward. No, run 1 here, sorry. It's a little awkward because of our scale of being 2 and we're starting on an odd number, so it's hard to get it exactly on the line. Use our straight edge. This was a mistake, okay? And then we'll graph the second line, and again, here I want to get y by itself, so I'm just going to add 2x to both sides, and I get y equals 2x plus 8. So here's my 8, and you can see that I can't really rise to 2x. I need to go down. So remember that negative 2 over negative 1 is the same thing, right? So if I go down 2, back 1, down 2, back 1, down 2, back 1, and you'll see that, oh, what's going on here? These lines never cross because they're parallel. Parallel lines never cross, so therefore, since they're not going to cross, there is no solution. Okay? We have a special name for this. It's called inconsistent. No solution because the lines are parallel, and won't cross. Now the opposite of inconsistent is consistent. So does anybody have any guesses as to what consistent systems have? Yes, they have one solution, which is their point of intersection. Okay, great. Now, what do you think about dependent systems? Dependent systems are going to have infinite solutions because they are the same line. So let's look and see what that looks like. For this example here, you might notice that everything from the first equation was multiplied by negative 2. So if I have x minus y equals 6, if I want to get this in slope y-intercept, I'm going to subtract x. Negative y equals negative x plus 6. I'm going to divide by negative 1, and I get y equals x minus 6. So negative 6 has a slope of 1. Rise 1, run 1, or rise 2, run 2, run 2. So here's my slope of 1. Now let's look at the second equation. Negative 2x plus 2y equals negative 12. The first thing I'm going to do is add 2x to both sides. I get 2y equals 2x minus 12. Divide everything by 2. Y equals x minus 6. It's the same exact line. So we will say this is a dependent system. It has infinite solutions, and all of the solutions exist on that line. Solutions, okay? This has no solution, and we call this system inconsistent. Okay, I'll pause this, stop this video, and start a new one for the next page.